We're going to start chapter 4. This chapter is about solving a system of linear equations and also solving a system of linear inequalities. So for this chapter, we're going to need to know that the system of linear equations is just a set of two or more linear equations. So for example, I have here one equation, a linear equation written in the standard form. So a1x plus b1y equals c1. And then I have another linear equation. So they have different coefficients. So that's the reason I'm using a sub 1 or b1 or c1. And in this case, a2, b2, and c2. So we're going to use the curly brace here to indicate that this is a system of linear equations. So the meaning of this is that we're indicating that these two equations are used to describe a phenomenon, a scientific problem. So all these equations operate at the same time. So that's the reason we need to consider this as a set, because we can have just two equations and they can be just two equations that have to do anything with the one with the other. So what are going to be the methods of solutions of system of linear equations? We're going to have basically three methods. We're going to have a graphing method that we're going to cover in section 4.1. Then we have the substitution method that is going to be described in section 4.2. And finally, the addition method, section 4.3. You're going to learn about these three methods, but later to solve your quizzes or your tests, you're going to use the method of your preference, unless I am asking you to use a specific method. Then we're going to have applications to system of linear equations. We're going to cover just 2 or 3 types of problems that we have in real life, and this is going to be on section 4.4. Then we're going to move to the last section of the chapter that is going to be about systems of linear inequalities. So again, it's going to be just a set now of linear inequalities. We're going to use again the curly brace to indicate that these inequalities are operating all together. So the only method that we have to solve system of linear inequalities is the graphing method. And this is going to be covered on section 4.5. So as you can see, for linear to solve the system of linear inequalities or system of linear equations, in both cases, we're going to need to learn about graphing. So actually, we already know how to graph a line. So we're going to apply just the methods that we learned. So we're going to have two ways to graph a linear equation. Either we use the intercepts or we use the y-intercept and the slope. So at this point, it's going to be up to you what method you're going to use to graph a linear equation. So we're going to start with the first section. So section 4.1 is solving system of linear equations by graphing. So this section starts on page 282. So let's work on this section now. So we have that when we have a system of linear equations, we use the graphing method. You're going to have one line for one of the equations and maybe another line for the other equation. So this might be a1x plus b1y equals c1, and this might be the graph of the equation a2x plus b2y equals c2, and the intersection point is going to be the solution. This is the solution of the system. The solution of the linear system. What linear system? Is going to be a1x plus b1y equals c1, A2x plus B2y equals C2. So we need to find the intersection point when we are solving a system of linear equations. And at the end, we need to verify that we obtain the actual solution of the system. We need to test the possible solution. So to test the possible solution, the only thing that we need to do is we need to evaluate the solution for one of the lines, then we evaluate the solution for the other line. And in both cases, we need to get true statements. So we're gonna start with that. We're gonna start testing solutions. So we're gonna test possible solutions of a linear system. So this is covered on the same page, 282. And to understand this, we're gonna solve just an example. So we have example 1 on the same page, and we're gonna have a system. So consider the system, and the system is comprised of these two equations, x plus 2y equals 2, x minus 2y equals 6. And now, imagine that we already did our graphs, or we use another of the other methods that we're going to learn later, and we found points. So we need to determine, we're going to determine if each ordered pair, is a solution of the system, is a solution of the system. This is important because you can have a point here that satisfies only one line but not the other, or you can have a point here that satisfies the other line but not the first one, or you can have a point here that doesn't satisfy either equation. So this is important to be sure that we did our work correctly. So I'm going to start with this solution. So we want to know whether this point is solution of this system. So we're going to do it in two steps. We're going to label our coordinates. So this is x and this is y. And then we're going to do the evaluation. So we're going to evaluate the first equation of the system, x plus 2y equals 2, 4x equals 4, and y equals -1. So we're gonna do what we have been doing so far. We're gonna replace x with 4 and y with -1. So we write 4 plus 2 times -1, and that should be equal to 2. We're gonna verify this, working on the left-hand side. So this is 4 plus positive times negative is gonna be just -2. So 4 minus 2 is 2, 2 equals 2, so this is true. So this point is a solution of this equation. Now we need to check that this is also a solution for the other equation. So we're going to evaluate now the other equation, x minus 2y equals 6, 4x equals 4, y equals -1. We are testing the same point. So we're going to replace again x with 4 and y with -1. So we have now 4 minus 2 times -1 equals 6. So let's see, 4 and negative times negative is going to be positive. 2 times 1 is going to be 2. So we get 6 on the left-hand side, we have 6 on the right-hand side. So now both equations are satisfied. So that means that the point for -1 is a solution of the linear system, the system that was provided at the very beginning, this one. So we found that this point satisfies both. So this point should be the intersection point of the graph of the two lines. So now we're gonna work a different point for this, the same system. So we have now another point to test. Now we have -4, +3. So again, this is my x, this is my y. I'm going to start with evaluating. Now I'm going to use again the first equation of the system, x plus 2y equals 2. I'm going to evaluate this equation for x equals -4, y equals 3. So that means that we're going to replace now x with -4 and y with 3. I get -4 plus 2 times 3 should be equal to 2. Let's see. So -4 plus 6. So this is -4 plus 6 is going to be 2. 2. So yeah, this point satisfies the first equation of the system. Now let's check the point with the second equation. So now we're going to evaluate. The second equation is x minus 2y equals 6, and we're going to evaluate this for x equals -4, y equals 3. So we replace x with -4, we replace y with 3. So we're going to get -4 minus 2 times 3 equals 6. So now I have -4 and negative times times positive is going to be negative. 2 times 3 is going to be 6. So I'm going to get -10 on the left hand side. I have 6 on the right hand side. So this point doesn't satisfy the second equation. So that means that the point with coordinates -4, 3 is not a solution of the linear system. What linear system? The system that was presented at the very beginning. This is the system. Okay, so now you're gonna work you're gonna work 3 exercises, and then we're gonna be ready to start finding the solutions. So you're gonna go and work on 4.1 exercise set on page 291. You're gonna determine whether the given order pair is a solution of the system. So you're gonna solve problem 2. So the possible solution is -2, -5, and the system is 6x minus 2y equals -2. Then you have 3x plus y equals -11. Then you're gonna solve problem 4. Problem 4, the point is 7/25, comma, -1/25. And the system is 4x plus 3y equals 1, 3x minus 4y equals 1. So this is the system where you're going to test whether this is the solution for this system. Then problem 6, the point is 10, 7. The system is 6x minus 5y equals 25. 4x plus 15y equals 13. So remember, in these problems, you are not finding the solution. You are given a possible solution. So the only thing that you're going to do, you're going to test whether the given point, the given solution, the given order pair is solution of the system. And meaning that this is the solution of the system is that this point is going to satisfy both equations, not only one. So you need to get true statements in both cases. So you're going to have now 10 minutes to work on this, and then we're going to come back and start finding solutions by using the graphing method. So now we're going to start finding solutions of linear systems. The first method that we're going to learn today is the graphing method. The graphing method is just get the graph of each of the lines and look for the intersection point. So we have two equations here. You can see here that these linear equations are written in the standard form. So we're going to use intercepts, the intercepts to find the graph. So equations written in the standard form can be plotted by using the intercepts. So let's start with the first equation. So my first equation, so we're gonna get, we're gonna graph 2x plus 3y equals 6. So that's the first step. We're gonna graph the first equation. So we're gonna use a small t-table with zeros in the diagonal. And remember, if x equals 0, you hide the term containing x and you read 3y equals 6. Then you solve for y by dividing by 3, which is the coefficient. So we're gonna get y equals 2. So we need to write here y equals 2. Now, in the other case, if y equals 0, we're gonna hide the y term and we're gonna read 2x equals 6. So I'm going to write 2x equals 6. We divide by 2 because 2 is the coefficient. So here we're gonna get x equals 3. So we write here 3. So now we have 2 points to get the graph of the first equation. The points, so we need to plot 0, 2 and 3, 0. So we're gonna do that in a minute. So let's find the intercepts for the second equation. So we're gonna graph the second equation, which is 2x plus y equals -2. We're gonna use another t-table with zeros in the diagonal. So for the y-intercept, we set x equals 0, meaning that we're gonna hide the x term. So we're gonna read y equals -2. Y equals -2. So that's already the value for y. y equals -2. In the other case, the x-intercept is found by setting y equals 0, meaning that we're gonna hide now the y term. And you can read on the screen 2x equals -2. So 2x equals -2. We divide by 2 both sides of the equation because 2 is the coefficient of x. So we end up with x equals -1. So now we have the two intercepts corresponding to the second equation. So we're gonna need to plot the points with coordinates 0, -2, and -1, 0. Then the third step, and the last one, is we need to find the intersection point. So find the intersection point. So we're gonna need then to plot the lines. We're gonna use our grid. So this is for these problems in the page 4. So the first line is just is going to be obtained by plotting 0, 2, and 3, 0. That's the first line. The other line is going to be 0, -2, -1, 0. So this is one line. This is 2x plus 3y equals 6. And these are the intercepts for 2x plus y equals -2. So let's put these points on the graph now. So we have the origin here. So in the first case, 0, 2 is going to be 0 is here. 0 means not move horizontally. So only 2 units. So this is the y-intercept. Then we have 3, 0. So 1, 2, 3, and 0. So these are the 2 points for the first line. So let's do that. So this is going to be, you need to use your grid paper because to find the intersection point is very important to be very precise as much as possible. So now the other line, 0, -2, 0, -2 is going to be here. And now -1, 0, -1, 0, that's the other point. So now we have 2 more points for the second line. So this is the first line. Now the second line is going to be plotted by using these 2 points. Okay. So we have the second line here. That's my second line. So this line has this equation. So now, what is the intersection point? You can see the intersection point here. So we only need to find the coordinates. What are the coordinates for this point? So it's going to be 1, 2, 3. It's 3 units on the left of the y-axis, and is 1, 2, 3, 4 units up from the x-axis. So it's going to be -3, 4. The coordinates of this point, -3, 4. Those are the units of the intersection point. So this is going to be the solution of the system. That's the solution of the system. So we're gonna write here that the solution is the solution of the linear system is the point with coordinates -3, 4. So that's example 2. Now we're gonna work another example. So we're gonna work now example 3. Example 3 is on page 285. So we're gonna solve by graphing. We're gonna solve the following system. So y equals -3x plus 2 and y equals 5x minus 6. So now you see the equations, the linear equations are written in a different form. So these equations are written in the slope-intercept form, in the slope-intercept form. So that means that we're gonna use now a different method to graph this equation. We're gonna use the y-intercept and the slope as a jumping recipe, if you remember. So we're gonna need just to find the slope and the intercept in the y-intercept in every case. So we're gonna have to graph first y equals -3x plus 2. So from here, remember we need to write y equals mx plus b. In that way, you're gonna be able to find m and b. So from here, we find that m equals -3 and b equals 2. So we need to write the slope as a fraction. So it's gonna be -3 over 1. So this is gonna be 3 down, 1 right. Remember, the numerator indicates the vertical shift, the denominator indicates the horizontal shift. So 3 down, 1 right, or you can put the negative sign here and positive here. So this is going to be equivalent to 3 up and 1 left. So the recipe, if you change the direction on both the numerator and the denominator, the direction that is indicated for the jumping recipe, then you're gonna get essentially the same direction. So the same slope. And the starting point is gonna be the point with coordinates 0, 2. That's the starting point. So that's the information that we need to create the first graph. Now let's work on the information for the second graph. For the second graph, the equation is y equals 5x minus 6. So we're gonna write again mx plus b to find m and to find b. So you can see here that m equals 5. M equals 5 and b equals -6. So that means that the jumping recipe is gonna be 5 over 1. So this is 5 up, 1 right, and this is equivalent to 5 down, 1 left. So we switch right to left, up to down, and the recipe is gonna work the same. And from here, you're gonna have 0, -6 to be the starting point. So the final step is just finding the intersection point. That is going to be the solution. Find the intersection point. So let's use this information on our read. So we're going to have now the following. So this is on page 4a. So we have first the starting point for the first equation is 0, 2. So 0, 2 is going to be here. So that is going to be the starting point. Let me move this a little bit up for you to see. So for the first equation, we have 0, 2, the starting point. So 0, 2 is here. That's the starting point for the first equation. Then we're going to move 3 down, 1 right. So 3 down, 1, 2, 3, 1 right is going to be here. 3 down, 1 right is going to be here. 3 down, 1 right is going to be here. Okay, so that's the recipe for the first one. So starting point, and or you can use 3 up, 1 left. That is going to be equivalent. 3 up, 1 left. So 1, 2, 3 up, 1 left is going to be here. 1, 2, 3 up, 1 left. So we're going to get a sequence of points. All of them are aligned. So because the recipe, the jumping recipe is the same. So let's line. So this is going to be the line. Okay. This is the first line. So this is the line with equation y equals -3 plus 2. So you can see here that the slope is negative, so the lines false. Now the other line, the starting point is 0, -6. So 1, 2, 3, 4, 5. This is -6. So this is the other starting point. Then I have 2 recipes. I can go 5 down and 1 left. It's not possible because I don't have more room in my. Then I want to use the other one, 5 up, 1 right. So 1, 2, 3, 4, 5 up, 1 right. So this is 1 point, 1, 2, 3, 4, 5, and 1 right. And I have these 3 points. So now I'm going to draw the second line. And the second line is this. So that's the second line. So we can write the equation for this line. So the equation is y equals yx minus 6. And you can see now the slope is positive, so the line rises. And we find very easily the intersection point. The intersection point now is this point with coordinates. This is 1, -1. 1, -1. So this point should be the solution of the system. So let's write here, solution of the system. So this is the graphing method to solve linear equations. So just to finish this part, I'm just going to write here the solution. So I'm going to write 1, -1 is the solution of the linear system. So that's the end of this problem. Now I'm going to give you 2 linear systems to solve by graphing, and then we're gonna move on to the first analytical method. And you're gonna see that you're seeing here 2 different ways to obtain graphs. When you have the equations written in the standard form, you use intercepts. When you have the equations written in the slope-intercept form, you use the y-intercept as a starting point and the slope as a jumping recipe. And the same thing is going to happen when we start working with analytical systems. You're going to see that the substitution method works better with this kind of equation. When you have the equations written in the slope-intercept form, the substitution method is preferred. When you have the equations written in the standard form, then you're going to use the addition method. So those are the 2 analytical methods that we're going to cover, and they are going to be very related to the form of the linear equations in the linear system. So let me write just for you the problem that you're going to solve, and I'm going to give you a break to work on those problems. So this is 4.1 exercise set. On page 291. So you're gonna work first problem 18. So remember, you're gonna solve the linear system by graphing. This is gonna be 5x minus y equals 10, 2x plus y equals 4. And then the other system is 24. So now you have y equals 3x minus 4, y equals negative 2x plus 1. So you have the 2 cases that we cover. So you're gonna use, in the first case, intercepts. In the second case, you're gonna use the y-intercept as the starting point and the slope to find the other points. So take some time to solve this problem, like maybe 15 minutes, and then we're gonna continue with the first analytical method. So now we're gonna start section 4.2 about solving system of linear equations by the substitution method. This is on page 294, and this is gonna be our first analytical method to find the solution of a linear system. So if you check your book on that page, you're gonna find a green box with the steps. I just copy basically those steps here. So the procedure is gonna be the following. You're gonna start solving one of the equations for one of the variables. So you need to examine those equations and choose the one that is gonna, in which you're gonna see that solving for one variable is gonna be the easiest one. So then once you have the solution or the expression from step 1, you're gonna substitute that expression into the other equation. When you do that, you're gonna get just an equation in one variable, a linear equation in one variable. So in step 3, you're gonna solve for that variable, for the remaining variable in the equation that you obtained from the previous step. Then by doing that, you're gonna get a value, a numerical value for one of your variables. So you're gonna back substitute that value into the equation that you obtained in the very first step. When you do that, you're gonna solve for the variable, solve for the variable, and then you're gonna find In that way, the numerical value for the second variable, then you're gonna test the solution. So you're gonna have a value for X and another value for Y. So you need to verify that both values satisfy both equations. So we're gonna start with example 1. So I have here example 1 on page 294. So we're gonna solve by the substitution method. Solve by the substitution method, and the system is the following system. So we have y equals negative x, negative 1, and 4x minus 3y equals 24. I used to label the equations with numbers. So this is going to be my equation 1. This is going to be my equation 2. And then you examine these equations. You need to solve for one variable in one of the equations. So here you have both variables on the left-hand side. And in the first equation, you have y on the left-hand side. So you already have, in the first equation, you have this equation solved for y. So my first step is just very easy. You just need to pick from equation 1. You have now the equation solved for y. So now you're gonna substitute into the other equation this expression. So you're gonna have to evaluate. So that's a substitution. You're gonna evaluate the other equation for x minus 3y equals 24 for the value of y that you have from the first step. So you're gonna replace y with negative x, negative 1. So we are evaluating now using expressions, algebraic expressions instead of numerical values, but the algebra that we're gonna apply is the same as before. So we're gonna write 4x minus 3 times, and then the expression negative x, negative 1, then equals 24. Then you just simplify the expression, and you're gonna get an equation, a linear equation now in one variable. Solve for that variable. So let's write here, we're gonna apply the distributive property. So this is most of the time the same steps that you're gonna follow. So we're gonna get 4x minus, negative times negative is gonna be positive, so you're gonna get 3x, negative times negative is gonna be positive, 3 times 1 is gonna be 3, equals 24. So we can combine these two. So we're gonna get 7x plus 3 equals 24. So I have a linear equation in one variable. So my third step is gonna be solving for the remaining variable. This is the remaining variable, x. So let's do that. So I'm going to have in my third step, I'm going to solve for x. So I have 7x plus 3 equals 24. So let's solve the equation. So let's see, I have to subtract 3 on both sides of the equation. So I'm going to get 7x equals 21. Then I divide by 7 because 7 is the coefficient of x. So I'm going to get x equals 3. Okay, so I'm going to back substitute this value we're gonna back substitute into the equation that we obtained from step 1, which is y equals negative x negative 1. That's the equation for step 1. So we're gonna back substitute. So we're gonna, in other words, we're gonna the back substitution step is just evaluating. We're gonna evaluate the first equation that we obtained from step 1. So y equals negative x negative 1 for the value that we just found here. So we're gonna have just to place x with 3. So we're gonna get y equals negative 3 negative 1. So y equals negative 4. So now you have two values, one for x, one for y. So the solution is a point with coordinates 3, negative 4. We still need to check that this is the solution. So let's do that. We're gonna do our testing. So we're gonna test 3, negative 4 for this system, the system that was given. So y equals negative x negative 1 and 4x minus 3y equals 24. That is the original system. So to test, we need to perform two evaluations. So we're gonna evaluate the first equation, 4x equals 3 and y equals negative 4. So we're gonna replace x with 3 and y with negative 4. So if we do that, we're gonna get negative 4 equals negative 3, negative 1. Then on the left, we still have negative 4. On the right, we're gonna have negative 3, negative 1 is negative 4. So that is correct. Then we perform the other evaluation. So the other evaluation is for the other equation for x minus 3y equals 24. And this evaluation is with x equals 3 and y equals negative 4. So again, we need to replace x with 3, negative 4, y with negative 4. So this is 4 times 3 minus 3 times negative 4. That should be equal to 24. Let's see whether that's true or not. So 4 times 3 is 12. Negative times negative is going to be positive. 3 times 4 is going to be 12. 12 plus 12 is 24. Here we have 24. So yeah, that's the solution for the system. So 3, negative 4 is the solution for the system. So now we're going to work 3 more problems. So that way you're going to be very, very well prepared for the assignment. So we're going to work now example 2. Example 2 is on page 295. We're going to solve by the substitution method the following linear system. So we have 5x minus 4y equals 9, x minus 2y equals negative 3. So now I have, this is my equation 1, this is my equation 2. In the first step, I need to solve for one of the variables in one of the equations. So as we did before, we look for variables with coefficient 1. So we have coefficient 5, coefficient negative 4, coefficient negative 2, and coefficient 1. Wow, this is good. So we need to solve for x here because it's the variable with the most friendly coefficient. So from 2, we have x minus 2y equals negative 3. So let's isolate x by adding 2y on both sides of the equation. So we're going to get x equals 2y minus 3. So that is going to be the expression I need to substitute into the other equation. So we're going to have now the following. We're going to evaluate the other equation. So the other equation is 5x minus 4y equals 9. And we're going to evaluate that equation for the expression that we found for x. So 2y minus 3. So we're going to replace x with this expression. So we're going to get 5 times 2y minus 3 minus 4y equals 9. So, so this is going to be solved by using the distributive properties. So we're going to get 10y minus 15 minus 4y equals 9. We combine like terms. 10y minus 4y is just 6y minus 15 equals 9. So the next step is we need to solve for y. So let's do that. So this is going to be the next step. So we're going to write our third step is just solving for y in this equation. So we need to add 15 to both sides of the equation, and we get 6y equals 24. Now we divide by the coefficient of y. So we're going to get y equals 4. That's the first value. We need to back substitute now. We need to back substitute into the expression that we obtained, into the equation that we obtained from step 1. So what was that expression? What was that equation? X equals 2y minus 3. So we need to back substitute into that equation. So this is going to be the back substitution step. So we're going to evaluate the equation from step 1, x equals 2y minus 3 for the value of the variable that we just obtained, y equals 4. So here we're going to replace y with 4. So we're going to get x equals 2 times 4 minus 3. So x equals a minus 3. So x equals 5. So now we have two values. So I have 5, 4. That's the solution that we need to test to be sure that we got the right answer. So you're gonna do it. You know how to do it now. So remember, the first step is, the last step is you need to evaluate every equation for x equals 5 and y equals 4. Now we're gonna solve one more example. This is going to be example 3. So, example 3. Okay, test the solution. Don't forget that. Example 3 is on page 296. We're going to solve the system. So 296. Solve the system that has the following equations. So y plus 1 equals 5 times x plus 1. The other one is y equals 5x minus 1. So I have my equation 1, I have my equation 2. I'm looking for variables with coefficient 1. So I have coefficient 1 here and coefficient 1 here. But in the second case, I already have the equation solved for one of the variables. So my first step is just from the second equation, I have y equals 5x minus 1. Okay, so now we're gonna do the substitution. So the substitution step is just evaluating the other equation. So y plus 1 equals 5x plus 1 for y equals 5x minus 1. So the equation that we obtained from the previous step. So we're going to replace y with this value, and we're going to solve the resulting equation. So we're going to get 5x minus 1, that's y, then plus 1, that is from the equation, equals 5 times x plus 1. So on the left-hand side, we get 5x. On the right-hand side, we need to apply the distributive property. So we're going to get 5x plus 5. So now in my third step, I need to solve for x. So I have my equation 5x equals 5x plus 5. If I subtract 5x and 5x from here and here, I get 0 on the left, 5 on the right. So the variable disappears. So when the variable disappears, you only need to check the final statement. If the final statement is true, you say that there are infinite number of solutions. So when the variable vanishes, just check the final statement. If true, then there are infinite number of solutions for the system. If false, there is no solution for the system. In this case, this is false. So this is false, so there is no solution for the system. In set notation, we use the empty set. So this is indicating that there are not points of intersection between the two lines, between these two lines. So graphically, that means that the lines are parallel. So they never intersect. They never intersect. intersect. That's when you get something like this, that the variable vanishes. So let's work one more example, and then you're gonna have work to do. So we're gonna work now example 4. So this is from page 297. Example 4, page 297. So we have another system. So the system. So now the system is y equals 3 minus 2x and 4x plus 2y equals 6. So this is my equation 1, this is my equation 2. So you can see that from 1, we already have one equation solved for one variable. So we have y equals 3 minus 2x. So we're gonna do the substitution by evaluating the other equation, 4x plus 2y equals 6, for the expression that we found for one of the variables in the first step. So we're gonna replace y with 3x, with 3 minus 2x. So we have 4x plus 2 times y is 3 minus 2x. Use parentheses when you have coefficients different than 1. And this is going to be equal to 6. So let's simplify this. We're going to get 4x plus 2 times 3 is 6. 2 times negative 2 is going to be negative 4x equals 6. So then we simplify here. So we're going to get 4x minus 4x is 0. So you get 6 equals 6. So again, the variable vanishes again. But in this case, the statement is true. So when the statement is true, you say that there are infinite number of solutions for the system. So in graphical terms, one line is on top of the other line. Essentially, it's the same line. So one line is on top of the same line. That's when you have infinite number of solutions. So I'm going to give you the assignment for this section. And with that, we're gonna finish our lecture for today. So this is gonna be 4.2, exercise set on page 300. So you're gonna solve each system. Solve each system by the substitution method. So we have 6 systems. You're gonna work just at least 3. So we have x plus y equals 6 and y equals 2x. Then I have problem 6. This is x plus 2y equals 5. 2x minus y equals negative 15. That's another system. Now problem 10. This is negative x plus 3y equals 10. 2x plus ay equals negative 6. That's number 10. Number 14, we have 6x plus 2y equals 7. Y equals 2 minus 3x. Then problem 18 is 4x plus 3y equals 0, 2x minus y equals 0, and finally 22. So we have x plus y minus 1 equals 2 times y minus x, and y equals 3x minus 1. So 6 problems. So you might work, for example, number 2, number 14, number 18 at least. And you're going to need to take screenshots of all your work from this lecture and just get a PDF file and submit your work. If you have questions, send me an email adding or attaching screenshots of your work, indicating the number of the problem and number of the page.